Okay. Okay, we are doing the second last of the chapter of the syllabus, chapter number 5, and we are looking for we are doing the first part of the chapter number 5, which is numerical differentiation. That means we are looking for the approximation of the derivative of the function at the given point. And we will use, inshallah, two formula for the approximation of the first derivative of the function at the given point, and one formula for the approximation of the second derivative of the function at the given point here. So we already start to the approximation of the first derivative, and we are doing the first numerical method, which we call is a 2-point formula. And I think 2-3 example last time. So let's take one more example concerning with the 2-point formula for the approximation of the first derivative of the function. This is a complete example we have here now. And let's say he say f of x is given x squared cosine x, h is given 0.1, and we have the 4-part. The compute the approximate value of the f dash. This is your alpha using 2-point formula. Then the second part, error bound. Third part, absolute error. And then accuracy given. And accuracy given mean always we have to use the error bound formula to find the best value or the maximum value of h to get the accuracy 10 minus 2. So first of all, as I say, you must be very good in the formula. What is the formula? F 2-point formula for the first derivative. It is x naught equal to what? F of x naught plus h minus f of x naught divided by h. You need two things. You need three things. You need f of x given by the teacher. You need x naught given by the teacher. You need h also given by the teacher. So nothing you have to do, only put the value and inshallah you get the answer of the problem. So what we have, x naught is given 1, h is given 0.1. The formula we have is f dash 1 plus h, which is 1.1. minus f of 1 divided by h. H is 0.1. So we can have here f of 1.1 minus f of 1 divided by 0.1. What is f of 1.1? You can easily find out in place, put in place of x is 1.1, and you can have this value minus in place of x, put 1, and you have this value. Simplify using calculator by radian sense. Then you, of course, you have this jawab, and this is the approximation. We finished the first part. And the second part, he said, compute the error bound. And I told you, I give you the error formula of the 2-point formula, which is minus h by 2 into the second derivative of eta. H is given 0.12, we know, and second derivative eta. Eta is unknown point. We don't know eta, only we know eta is majud inside the open interval. So when we find error bound, we always find the maximum value. So we will find m the same like in chapter number 4, and m is what? The maximum value of the second derivative of the function inside the interval. So when you know this one, then you can easily use the error bound formula. So first thing, you have to find the second derivative of the function. Your function is given x squared cosine x. And then you can find the first derivative is this one, and the second derivative you can find out. Then check second derivative at the interval. Or when we check in the interval, generally we check in the end point of the interval. We check at second derivative at 1 and 1.1. Then maximum is majud at 1.1, which is 3.5630. So now we can use this formula easily. is less than equal to, error bound is what? Less than equal to h by 2, h is 0.1 by 2 into m. M is the maximum value of the second derivative. And that you can put the value here and you have, this is the possible maximum error or the error bound for the approximation of f-1. The third part he said, compute the absolute error. We already have we know what is absolute error, exact minus approximation. And we already have the approximation is this one. And the exact is your f-1. So you need first derivative. You already have the first derivative, this one. You need to find f dash at 1. Put in place of x is 1 and you simplify by using calculator. Inshallah, you will get, this is the approximation. This is exact value, this is approximate, and this is the possible, the absolute error. And third part, he say that to get the accuracy with the help of 2-point formula, find the best value of h. And we know this is the error bound formula, which I told you before. And this is given 10 minus 2. So it means you need to find out h. You already know m. M is a maximum value, which we calculate before. We calculated m here, which is 3.5630. Use this maximum value here. M will come in the denominator, 2 will go up, and then you simplify this one. This is your h here. That's a complete question here. Last time, I never say find the best value of h. In the exam, I can give you 3 questions, different way. The first way, find the h. And no, this is a way you can find h. M, we know, accuracy given, we can simplify. Sometime in exam, teachers say find n, number of subinterval. And what is the formula of n, which I give you last time? N is what? B minus A divided by h. What is your interval? Your interval is 1 to 1.1. So B is your 1.1, A is your 1, h you just find out is this one. And that will give you the value of n here. If you can use, for example, according to this question, is 1.1 minus 1 divided by what? 0.0056. Let's say how much you got here. If you use calculator, you have 0.1 divided by 0.0056, and you will get the answer is 17.86. So of course, n is a integer. So it means you have to take very next integer, which is what?
18.
18. Maybe in exam, teacher never say h, he never say n. He can give you the third option. And third option is what? Number of the points. And I told you what is the number of points formula last time. Number of points always equal to what? N plus 1. So what is the job here? Is a 19, because you already know n is what? 18. 18 plus 1 is the number. And in this chapter, please, in chapter number 4, we know what is n we call n is the degree of the polynomial. But in chapter number 5, what we call n is a number of subinterval. So of course, if you have 18 interval, how many points you have? Point always one bigger. It is 19 points. So this is a 3 different way we can ask in the exam. Teacher can ask you the h. Simply use this. If we say find n, you find h, use the formula this, you find out the number of subinterval. If you say number of point always equal to the n plus 1 we have. This is, you have the 2-point formula. Very simple, very easy. How to deal with this one here. So 2-point formula mean you are given 1 point by the teacher. One you have to pick yourself, and that point you can simply pick by taking h, because you know the next point will x naught, and x1 is what? X naught plus h. So that you can find out the 2 points and then you can solve it. I give 4 example for this one here. The first example, when I say find the eta last time by using error formula, that's a very good example. And this example is also very good here. Complete idea for this one. The 2-point formula is not the tricky one here. The basically the 3-point formula, which will do the second numerical method, because I told you to find the approximation of the first derivative of the function, we have to use 2 formula. We finished the first formula, which is a 2-point formula. Now we have 3-point formula. Yes, this is a good one here. Here you must be very careful now. In the 3-point formula, how many points we need? We need 3 points, x0, x1, and x2. And the distance between them should be equally spaced, should be equally the space here. And in the 3-point formula, we can have a 3 possible case. If you are given information at x0, find the derivative of the function at x0. It means you need 2 more points. And that 2 more points you need on the right-hand side of x0, which means this type of formula, if you need the right side, 2 points on the right side of the given point, then we call it a forward difference formula. The second case is, maybe teacher say find the value of the approximation of the derivative of the function at x1. So when he say x1, it means you need 1 point on the right side and the other point on the left side, and this is called central difference formula. If teacher give you x2, then of course to use 3-point formula for approximation of the function at x2, we need 2 points on the left-hand side of the x2, which is x0 and x1. And that formula we call is a backward difference formula. So we have 3 cases in the 3-point formula for the approximation of the first derivative of the function. Maybe the forward difference, maybe the center difference, maybe the backward difference formula. That's the things as I mentioned you here. If you need to find the approximation of the derivative of the function at x0, x0 is given, you need 2 more points on the right hand side, therefore we call forward difference 3-point formula. If you are given f dash at x1, so x1 is given, so you need 1 point on the right side, 1 on the left. This is called the central difference formula. And if you are asking the question, find the derivative of x2, then of course you need 2 points on the left side, x0 and x1. But in exam, the good point here, in exam, teacher never say the center one or backward one or forward one. 99% chance in exam, teacher say use the 3-point formula for the smaller value of h. So what you do, you check if I use forward, I need 2 points on the right side, and then right side point should be equally spaced with the given point. And for center, 1 left, 1 right, same distance, and backward 2 points on the left, same. Then you say which give you the smaller value of h, use that formula. Okay, let's I give you the first, I give you the center difference formula. This is a central difference 3-point formula, which is f dash as x1 approximation to f of x2 minus f of x naught. I convert x2 in the form of x1. I convert x0 in the form of x1. So this is very simple to calculation because x1 is given, h we know, then you directly, you no need to discuss x2. So convert your x2 in the form of x1, convert your x0 in the form of x1. So we have, this is the formula, you remember that one. Because we know what is x2. x2 always equal to x1 plus h1. And what is your x1? Your x1 always equal to x0 plus h because the distance between the point is the equidistant. And the error formula, the error term of the central difference formula is minus h squared taqsim by 6, the third derivative at eta. This is the error formula we have for the central difference formula. So this is a complete formula I write here. I write is equal because if you write the approximate formula together with the error, we always write equal, otherwise no need to write equal here. The same way I give you the other two formula. Before I give you the other formula, I give you one of the example here. And it is mentioned by directly use the 3 center difference formula. If teacher say use center difference formula, so it's mean directly you use here. As I told you, generally if we say use the best 3-point formula, this is a question. Please remember this way the teacher can give you 2 different ways. One way, he give you use the best 3-point formula. When teacher say use the best 3-point formula, you always go for the central. But if we say use the best 3-point formula for the smaller value of h, then you have to think which one give you the smaller value of. I will give you inshallah example for all cases. Let's give the first case. He give you f of x is equal to x squared cosine x, h is equal to 0.1. Then we do the same thing. First, we find the approximation by using the center difference formula, error bound, absolute error, and the best value of h. Same way we did in the case of the 2-point formula. So first job, you have to write the formula. And the formula, what is the formula? F of x1 plus h minus f of x1 minus h taqsim by 2h. So now you can see what is your x1 given? 1. What is your h given? 0.1. So you can have here f of 1 plus h minus f of 1 minus h taqsim by 2h. And you can have simplify 1.1 minus 0.9. And now you can easily find out the function value at 1.1 because function is given this. So 1.1 is what? 1.1 square plus cosine 1.1. This is, and what is minus f of 0.9? Put in place of x is a 0.9. So you have 0.9 square plus cosine 0.9. Use radian sense calculator, and you can have, this is the approximation by the 3-point central difference formula. Now, what is the second part? He said compute the error bound. Error bound mean the maximum error, and we need the error term. We know what is the error term of central. It's h squared by 6. So we take absolute sense, and the third derivative we have here now. So here what we have to do, please. We need the maximum value of the third derivative inside the interval here, which we call m, same thing. So it's mean your function is given x squared plus cosine x. If you find the third derivative, very, very simple third derivative, and the third derivative is the sine. And you have to find, you need to find the maximum value of the third derivative inside the interval. Interval is from 0.9 to 1.1. And the maximum value at sine at this point you can find. It will give you inshallah. This one you need to find sine at 0.9 and sign at 1.9 and then take the maximum here. And now you can easily find out the error is what? H square, which is 0.1 square because H is your this one. 6m you are given, you calculate it like this one, not given, calculate it like this, and this is you got the possible maximum error. And then teacher can ask you the absolute error, and we know absolute error formula is what? The absolute error mean the exact is f-1 and approximate, we just find approximate is there 1.16, and this first derivative is 2 minus sine x, in place of x put 1, so you have this one, calculate this value and this you will get the absolute error. And then the fourth part is say find the best value of h, and we know this is the error formula for error bound formula of the central difference, and then given accuracy is this 10 minus 2, so you take m in the denominator, 6 go up, and then you find h square. You need h, take the square root on both sides, so this you will end with this one. So put the value of m, which we already calculated in the previous step, which is this, and that give you the possible value of h. And again, teacher can give you here he say find h. Maybe in exam teacher say not h, he can say find number of subintervals, which I told you how to find, or find the number of points. The same way you can do please that. But in exam, the chances of this example is very small because here nothing. You never think about this one. In exam, teacher generally give you the table, and from the table you have to pick the points here. This is a good example, and he never give you the name of the method. He only say use 3-point formula for the smaller value of h. That I give you now here. Before I give you the other two possible formula please. We already know the central 3-point formula. Now I give you the 3-point forward and backward difference formula. And this formula is called the 3-point forward difference formula. It is x0, x1, and x2. So I convert x1 in the form of x0. I convert x2 into the form of x0. So we have this. So you can see this is the formula we have. The 3-point forward difference formula. And what is its error term? The error term is this one. What is the error term of central? If you remember, the error term of central was what? Minus h square by 6. And here you have the third derivative. And this is your the third and the final case formula 3-point. This is called the backward difference formula. And this is x2, this is x1, and I convert x1 into the form of x2. I convert x0 into the form of x2. So we have this shape of the formula. And what is the error term of the backward difference formula? The error term of backward difference formula and the forward difference formula exactly the same. But the error formula of the central is minus h square taxim by 6 third derivative. You remember, as I told you, if teacher say use the best 3-point formula, we generally use always the central one. Why we use central one? Because the error term of central one is smaller than this one. Because for forward, what we have? H square by 3. Backward, h square by 3 into third derivative. But error term of central is what? Is minus h square by 6. So smaller the error, better the function we have here now. Let's we do one of the best example from examination point of view, and this is a good example here now, please. This type of the problem will come in the exam. I will ask you the question from you. He say use the 3-point formula for the smaller value of h to find the approximation of f dash 3. This 3 may be x0, maybe x1, maybe x2. We don't know. We have to check. Let's say if it is x0, and we want to use forward difference formula, what we need, please? We need 2 more points on the right hand side with the equally space. Which 2 points you will choose, please, on the right hand side equally space? Any student?
3.9 and 4.8.
Yes, we have 2 choices. 3.9 and 4.9 because the distance is same. Or we can use 4 and the 5. Distance is same. But if we choose 3.9 and 4.8 over h is what? 0.9. So x1 will be what? 3.9 and x2 will be what? 4.8, right? And this will give you what? H given what? The 9. Here a student confused, please, in exam. When they say forward difference, they say 2 points on the right hand side, they choose 3.9 and 4. No, the distance should be equally spaced. And sometimes, like, you have 2 options, but you have to choose the option of smaller h. If you use 4, 5, it means h is equal to 1. No, you have to do. Let's say we want to use central one. Then we call x3 is a central one. So we need 1 point on the left and 1 on the right. Left we have 2. Which point you will choose for this one, please?
2.
2 and 4.
2 and
4.
How can you have 2 and 4? Yes, you can use 2 and 4. What is the distance between them?
1. H equal to 1.
We have another chance here or no? Did you check all this one? We have 2.48 is a 2, not this. 2.3 is a 0.7, not this. It means we have only one choices, which is 2 and
4.
Is a 4. And this give you what? This give you h is equal to what?
1.
1.
Good. Now let's say if your x2 is 3, which means the backward difference formula. So we need what? 2 points on the left side, x0 and x1, equally spaced. Which point you will choose, please? Not you, please. You are, I think,
1.6.
Yes, what?
1.6 and 2.3 or 2.3.
Yes, we can. We have 2 choices. One is 2 and 1, right? Equally spaced, but h is 1. But if we choose 2.3 and 1.6, your h is a 0.7. So it's mean what is your x1 should be 2.3, and what is your x0? 1.6, and this give you h what?
0.7.
So it means
0.7.
so yes, it means the best formula for in this sense, for the sense of smaller h, is the backward. This is the, if you understand this point, please, voila, this part of the chapter is nothing here, because only the selection of the point. For the 2 point, no need for the selection. 2 point mean we need 1 on the left or 1 on the right, maybe, which give you the smaller, easy. But for the 3 point formula, 1 point given, we have to pick 2 point should be equally spaced. Therefore, sometimes we have to jump it. Not teacher never give you the regular way equally spaced. He give you mix. Then you have to pick yourself here. So it's mean now we are deciding the formula. The best formula, smaller value of h is this. So that's I give you for all the three option here, that if I want to use center difference formula, I have this shape, this point, this giving me h. If I want to use forward difference formula, I have this choice and I use h with 0.9. But if I use the backward difference formula, this give you the best choice of h. Best choice of h means the smaller value of h here. So it's mean for our question, we have to use backward difference formula. And backward difference formula, I told you, is this one. F of x2. X2 is your 3. This is x1 and this is x0. And this formula you use, simplify your given the value of the table. What is f of 1, 6 given 0.47? What is f of 2, 3 is given 0.83? And what is f of 3 given 1.1? And you use a calculator and you have this job here. But please, even your h value is what? Is 1, which is very big than this one. But if you solve by center, your job may be better than this one. But we are not asking the best approximation. We are asking what?
Smaller value of
The
h.
smaller value of h here. That's the question we have. We are not asking for the best formula. We are asking the formula for the smaller value of h. Because sometimes even your h is big in the central, but still give you the better approximation than the forward and the backward. Therefore, teacher always say like this one, use the smaller value h formula, 3 points. So you have to check all three possible. Okay, next, this is the formula we have. What is the next one? He said find the error bond, and to find error bond, we need the error term, and this is the error term I give you for the case of backward difference formula. We know h is what? 0.7. We don't know this one. It means we find the maximum value of the derivative. This is the things we have to do here. And this is the maximum value of the derivative in this sense here. This is m. This is m. And that we can find out is this one. The second derivative. No. I'm not doing the b part here. We finished the first part. Now, sorry. Come to the B part here. The B part, he say, this table is for which function? Is the Linux. Because in this question, your function is not given, your table given. But what is the value of f is not given, so we don't need. But when we find the error bond, we need the derivative of the function. It means we should have the formula of f. So here given teacher give you second part. He say the table given for in the first part is the Linux. Now he say find the error bond. So it's mean I already give you the error bond formula is this one. So third derivative of Linux you can easily find out is this one. And the interval is your what? 1.6 to 3. You find the maximum value if your function in the denominator maximum always measured at the smallest point. So this is the maximum value you will get for the m. H you already know, which is 0.7. So you put the value of in this formula h 0.7 by 2, 3. And this is m, the second, the maximum value of the third, which you put. And this is the possible. And the fourth part, he can give you what? He can give you define the absolute error. And absolute error is what? The exact minus approximation. Approximation, we just find out 2.6527. And exact, how can you find? Your function is ln x. What is the derivative?
1 over x.
Now this is here. Now which question is this one? Now this is another question. Sorry, I'm not talking. This is another example. Sorry. We are jumping now. Therefore, I say confused. Which one we are doing? We are doing, sorry, this one. We are doing this one. And now, what is the fourth part, please? The fourth part, he say, what is the best maximum value of the third part? No error, absolute error we calculate from here. What is the best maximum value? The same thing we have here now. We use the error. This is error bond we find. This is the absolute error. Inshallah, you will find. Absolute error is what? F dash at 3. This is approximate value. F dash 3 is what? What is the function? Ln x. What is the derivative? 1 over x. And x is 3. So 1 over 3 is what? 0.333. So you have this error. And then he say find the value of h. This is the error formula of the backward difference formula. H square taqseem by 3 into m. M is the maximum value in the interval in the third derivative. So you already know m. H you can find out. This give you the h square formula. Take the square root on both sides, and this will give you the simple things we have here. Right. So when teachers say use, let's let me ask you the question here. We have 3-point formula. 3 I give you. What is central? F dash x1 approximate f of x1 plus h
minus f
minus
x1
f of x1 minus h same by
2h.
2h. Good. What is the forward? Just I write directly. Forward is what? F of x naught equal to 3 f of x naught plus 4 f of x naught plus
h
minus f of x naught plus
2h.
same by 2h. And the last one, backward, f dash is equal to what? x2. This is equal to what? The only thing is now, I told you, what is the difference between forward and backward? The difference is this h. If you put h is minus h in the forward, it becomes backward here. So when you have here, replace x naught by x2 and h by minus h, and then you can have here now it will be what? 3 f of x2. Why I put this in plus 3? Because you taqseem by minus 2h. So this minus will multiply up, it make like this one, negative to positive, positive to negative, like this one, right? Minus 4 f of x2 minus h and plus f of x2 minus 2h taqseem by 2x. Now I give you the formula in front of you, everything in front of you. You have to give me the answer one. I give this problem the same. And I say use the smaller value of h at 3. Right? Then you do what? Then you check, can I use central? Can I use forward or backward. It depends on the h. And we did like this example. Let's say 3 is not given in the table, right? 3 is not given in the table. And the question is again, find f dash at 3 by using smaller value of h. How can you use? Which one you use? Just look the formula. You can give the jawab in 1 second. Look the formula only. He say
Central,
is a central. Why?
because we don't need 3.
Yeah, we don't need 3 here because for forward we need 3 x naught. For backward we need x2, which is 3. But for central we don't need f of x1. We need only the right and
The left.
left. It's mean if you're not given this point, it means we have always one choice, which is what? The central. But if 3 is given in the table, then we can have 3 choices. We have to check all 3 possible choices, please. Good one. Like the same example I give here. Use the best. Now, I will never say best in the exam. I always say in the exam is what? Smaller value of h 3-point formula. And 1.5 is not given here. Right? So 1.5 is not given. So it means we cannot use the forward. We cannot use the backward. Only we can use is what?
Central.
Center. And for equally spaced 1.5, what point you can choose?
1 and 2.
1 and 2 here. This is the only choice we have, the best choice we can have here now, which I use here, and we find the part. Let's I give you this example now. No, this is not here. Here, in this example, I use the both cases, and in exam, teacher cannot give you the all 3 cases together. In exam, teacher can mention you either central or forward or backward. But I say here, if my f of x is equal to this one, I just give you the idea, but generally is not given in the exam. Is the f of x is equal to this one, he say use most accurate 3-point formula to determine the missing term. So how can you find f dash here? Which formula you can use? When you find f dash at 2?
Forward.
Forward, we need this 2 and like. If we need f dash at 2.1, what we need?
Central.
Center. If we need 2.2, what we need?
Backward.
Backward. So that's the things I say. Which suitable formula use f dash at 2, which suitable formula use at f2.1, which you use at 2.1, 2.2, and then calculate the absolute error and the error bond. And of course, this is 3 times we have to use. I solve all 3 here, and then I fail, and this I complete the table. But in the exam, this is not possible. Okay, I give you this also one more trick here. Okay, this question is come. Let f of x is equal to x ln x plus x, and x is equal to 0.9, 1.3, 1.6, 2.1, 2.5, 3.1. Then I say, find the approximate value of f dash at 1.9 using the 3-point formula for the smaller value of h. Which formula you will use, please?
Central.
Think about again.
Backward.
Why backward?
Because 1.6 and 1.3.
No, the things here. Remember you one point I told you. I say if the point is not majud in the x value, we can always use the center one, right? But the problem is teacher give you
11.
the function. So when he give you the function, if we don't care it majuz or not, because 1.9 we can easily find out the value of the function. You understand my point? In this example, go back to this example which we just finished. This example, as I told you, if 3 is not given, we have to use the center one. Why we use center one? Because for the first part of the question, we have no information of the function. So when we have no information of the function, so of course, we have only one choice, which is the central. But in this question, teacher already give you in the first part the function value. So when he give you the function value, then now you can have a easily to find out this one. Now you can choose. So 1.9 is here. This is 1.9 here. And when 1.9 is here, so you can use the best formula is again backward for this case here, because this is only give you the best choice here. I just give you, if I use the center difference formula, I have this information. I need, this is given by the teacher. I need one on the right, one on the left, which is 1.3 and 2.6. What is your H for this case? Is a 0.6, I'm right? If I use backward, forward, I need this point. Again, what is your H? 0.6. But if I use backward difference formula, my choice should be this one. This is given by the teacher. This I choose, and my H is what? The 0.3. And then you use the backward difference formula. We continue, inshallah. We complete this example on next time here. And one thing you have to understand, if your function is given, the point is given in the table or not, we don't care. We can easily find. But if function is not given in the first part, then we cannot find out the value of the function in the table. So only choice is center difference file. Let's stop the record.